Louder.
Objective. I will identify corresponding parts of triangles.
Very nice. So hi guys. The last couple of class sessions that we've met, we talked about classifying triangles. You know, the acute or obtuse, right or scalene, isosceles, all of those. And then we talked about what happens when we add up the measures of all the angles in the triangle. When we add them all up, what number do we get?
180.
180. Very nice. Leading from that theorem, they add up to 180. We had a theorem that showed us the exterior angle. You remember that one? Where we had the two remote interior angles adding together? What did remote mean? Far away. Very, very nice. Today's conversation is going to be about congruent triangles. Triangles that are the same size and the same shape as each other. Let's take a moment to figure out what we mean by these corresponding parts, because that's what was here in the definition of congruent polygons. So in order for parts of triangles, hey, Jose, I'm over here.
Sorry.
Thank you. In order for us to look at the different parts of triangles and to talk about them being corresponding, let's imagine it as my hands. Okay? So we're looking at our hands. Here are my hands. And we need to know which parts are corresponding if my hands were congruent. What would I need to do to get my hands to line up?
Like put them in line.
Put them in line. He said flip one. So I'm going to take one and I'm going to reflect it.
And you reflect that other one too.
I reflect the other one too? No. Nope. The thumbs are now facing a different way. So back to here. Now what? How do I get one on top of the other?
You shift it.
Shift it. What's the proper word for slide?
Translation.
Translation. Now what?
Rotation.
Now the rotation. And now they're lined up perfectly together. You see? When my hands are like this, when my shapes are lined up one on top of the other, we've got corresponding parts. My thumbs line up, those are corresponding. My pinkies line up, those are corresponding. My middle fingers line up, those are corresponding. So what this bottom line here, the very bottom line that we wrote in our notes, corresponding parts of congruent triangles are congruent. Abbreviated, because that's a lot of words, abbreviated as CPCTC. That's not any better, but we'll go with it. What this one sentence is trying to say is this. If I have two shapes, like my hands, and I can show that all of those corresponding parts are congruent, then I can say that the shapes themselves are congruent. Make sense, Mr. Aja? A little bit. It also says this. If I know that these two shapes are congruent to each other, then I can say that all the different pieces that correspond are going to be congruent to each other. This one sentence allows me to go from congruent shape to congruent parts, or from congruent parts to congruent shapes. Exactly. And we're going to use that on our practice example to show that shapes are congruent. Before we get there, however, I need to talk a little bit about about how we write congruent statements. When we write congruent statements, we're talking about two different shapes. Here's the first shape being congruent, and here's the second shape that it's being congruent to. The order in which you write those corresponding parts are important. If I were to say my hand, right here, is congruent to my other hand, and I start on your left, my right, okay? So if I start here by naming my hand, thumb, index, middle, ring, pinky, I have to make sure I say the name of my other hand in that order. So if I do it left to right, the same direction I did with this hand, then this one's name is pinky, ring, middle, index, thumb. That's not the same order.
No, it is not.
Always, when you're writing your congruent statement, make sure you write them in the same order. Super, super important. Before we get to the examples, the last thing to talk about is this third angles theorem. The third angles theorem says that if you've got two triangles, and you know that you've got two pairs within those two triangles of angles being congruent, that third pair had to be congruent. Does that make sense? Yes? So the question is, why is that true? Why does that happen? What's the proof for this theorem? I'm going to talk you through it. And ladies and gentlemen, I would really, really like that you work with me on this little proof demo. Okay, we're not going to do a formal proof. We're just going to talk about it. So that way you have the answer for a proof that I'm going to give you another day. Okay? Okay. So I'm going to zoom in here on these triangles. Zooming in nice and close. Focus. Camera, focus. Okay. Notice how angle B has congruent marks to angle J. And angle C has congruent mark to angle K. That means their measures are equal. Can I have some measures for these angles, please?
76.
76
89.
and 80. I heard 69, but it came right after 80. So hold that number for another day.
Okay.
Okay. Now, I have this one triangle on the left. Yes, triangle ABC. What's the measure of the third angle? How would you find that? You add them and then subtract from? 180. Triangle angle sum gave you that, yes?
Yes.
Bust out your calculator apps. Do it. Once you get your answer, shout it as loud as you possibly can. I want next door for them to come running over and go, you're being too loud. Stop it.
Somebody yell.
Somebody yell as soon as you know what that is. Calculator app to the rescue.
140.
140.
That
That sounds weird. And it sounds weird because if I take 140 and I add it to 80 and I add it to 76, I'm going to get something way bigger than 180.
It's 8.
It's 8. It's 24. 24 sounds more reasonable.
Shout it though.
Shout it.
Yeah.
24.
Loud enough.
We'll take it. 24 degrees. He added the two blue numbers. He subtracted that value from 180. All right, let's look at our second triangle. B is congruent to J. So J's measure is?
15.
B is congruent to J. It's 76 because congruent means same size. C is congruent to K. What is K's measure? Jose, forward please. 80. Because K has the same measure as angle C.
So then angle L will be
How do you know angle L is 24?
because they're all the same.
But if I don't know they're the same, what could I do to find the measure of angle L?
Add them up, add subtract from 180.
Exactly. This, ladies and gentlemen, is the proof for the third angles theorem. When you get the proof packet to do for the third angles theorem, I encourage you to come back to this episode, find this portion of the lecture, and rewatch it so you can use it as your guideline to write that formal proof. All right? Let's do the examples on the study guide.
There's no word to do to them.
Pick a number between 1 and 6.
7. 8. 5.
5. Between 1 and 6.
Oh, my God.
We're looking at number 5. That's the number that got called out first. The directions for this section ask us to confirm that these triangles are congruent by stating which corresponding parts are congruent. Once we know the shapes are congruent, because we have all their parts congruent, we're going to write the statement that says they're congruent. Okay? First off, I know that this segment and this segment are congruent because there's one mark. I know that these two segments are congruent because there's a mark there. Yeah. Hi, guys. I know that this angle is congruent to this angle because there's a mark there.
The lines.
Yep. And I know that this angle is congruent to this angle because
The mark.
there's a mark there. And I know that this angle is congruent to this angle because
The marks.
there's a mark there.
The marks.
All right. So we have Jose. We have 3 pairs of angles congruent to each other and 2 pairs of sides congruent to each other. How many more sides do we need? We need to show all 3 pairs of sides are congruent. We only have 2 pairs of sides.
So then you need one more.
We need 1 more pair of sides. Let's go find that 1 more pair of sides. All right, looking at this bottom triangle, I see that this side of that triangle doesn't have a congruence mark, yes?
Yes.
Correct.
Okay. And now looking at the top triangle, I see that this side of that top triangle doesn't have a congruence mark on it, right?
Yes.
Which means I need to say that this segment for this triangle is congruent to this segment for this triangle. Wait a minute, it's the same segment.
So they're the same.
They're the same. We can automatically state that this segment is congruent to itself. Duh. But what's the proper name of the property that allows us to say a thing is congruent to itself?
Oh my God, it's so much.
Notes from yesterday. Under properties of congruence, find it. Find it. Notes from yesterday, properties of congruence, the property that lets us say a thing is congruent to itself. Go. Which one?
Corresponding angles?
No, not corresponding angles. You went a little too far.
Let me see, miss.
If you want.
No.
That's it.
Hey, don't harass the visitor from another class period.
No, miss, I know.
He's already got the inside joke on this one. He saw this as lecture already.
Oh, it's a joke?
No, it's an actual property. Look for yesterday. Jackie, 4-2. The notes for 4-2 I just gave you. Under properties of congruence. Do you want a hint? It starts with an R.
Rectangle.
Starts with R. It's not rectangle.
Reflexive property of congruence.
Yes, reflexive property of congruence.
Right there. I almost had it, miss.
It's all right. You'll get it next time, right?
Next time.
Next time.
Next year.
So, do I have all the corresponding parts of these triangles congruent?
Yes.
Yes. Let's write the congruent statement. Jose, you're with me?
Yes.
Let's do it. Roll up your sleeves. Let's write that congruent statement. Which triangle are we going to write first? The one on the bottom or the one on the top?
Bottom.
The bottom. Okay. Name it. Triangle ABC. All right. Triangle ABC is congruent to. Now be careful.
ZJE.
DBC.
Vertex A corresponds to vertex what? D. B corresponds to,
C.
and C corresponds to,
A.
I heard it.
I was right.
You were right. You have to be very careful when writing these congruent statements. I am going to check that you have them in the right order. Because like we did with my hands, if you write them in the wrong order, they don't line up properly. Make sense? All right, let's look at number 7 and 8. Which one do you want to do?
8.
8 it is. This is the one we're doing. We're going to find the value of x. And we're being told that triangle ABC is congruent to triangle DEF. With me so far? All right, let's come over to the picture. Over to the picture. Stay with me, guys. Hey, guys. Thank you. Thank you. All right. Angle A is congruent to angle D. Angle B is congruent to angle E. Thank you. Angle C is congruent to angle F. Alrighty. I want to find the value of y. Notice that the value of y by itself is the measure of angle D. And D corresponds with A. Were we told these triangles are congruent?
Yes.
Yes. Then because the triangles are congruent, their corresponding parts are congruent. Angle D, shh, guys, gentlemen, thank you. Angle D is congruent to angle A. That means the measure of angle D is equal to the measure of angle A. Yeah, that means it's going to be 65, but let's do this mindlessly. What do we have listed as the measure of angle D?
2y minus 5.
2y minus 5. What do we have listed as the measure of angle A?
65.
And now you get to pretend you are no longer in geometry, and you get to pretend you're in algebra. Solve this for y. You're saying add 5 to both sides, and we get 2y equals 70?
2 times 35 minus 5 is 65.
Hey, please remember, at the very least, whenever you have an algebra component on your homeworks right now, you must show all of your work. I'm still getting papers, guys. I'm still getting papers with just answers. And I know that you guys are so much smarter than me. I know that you can look at it, think all the work in your head, and just write down the answers. But if your shortcut is going to hurt you in the long run, I need to see what you're doing so I can fix it for you. Okay? Please write down what you're thinking, all of your algebra steps, so I can make sure that it's not going to break on you. All right? Okay?